Hi, I'm Bob Vila. Welcome home again. Today, the house gets a fresh coat of paint. We'll be using a new kind of paint with low volatile organic compounds on the interior. Also, we'll get together with Red Anderson from the National Renewable Energy Labs and test how well the SIPS panels are insulating the house. Ryley and Steve Parks will be installing interior doors, and we'll visit the Simpson Door manufacturing plant in McCleary, Washington. So stick around. It's great to have you home again.
Sears presents Bob Vila's Home Again.
All right, let's take a minute and look at the work so that we can get a report on the progress from you. If you can see this side, the staging's still up, but it'll be coming down later today. We've already put a coat of finish paint on all the siding, and the ladies, some of the volunteers back there, are already working on cleaning up all the rubble and the rocks that's strewn there. Up on the top, you can see a couple of the guys are applying a coat of white paint. And we're using a paint that actually can be put on the house even when the temperatures go down as much as 35 degrees. A nice coat of white paint on the rake boards up there. And if you notice down here, we don't have the siding in place yet. The fire inspector didn't want us to put any further work here until we'd built the front porch. And so we've got that now, and that means that there's a good means of egress from the house. We've got so many people here that there was a concern about safety. And over on this side of the house, you can see we've got about a dozen volunteers applying that low temp 35 from Sherwin-Williams, which again makes it possible to be doing this even when the weather gets a little bit cold. Inside, our painting contractor, who's also volunteering, Tyghe O'Donnell, was here until midnight last night. He really put in an all-nighter painting some of the interior of the house.
What we're doing now is just putting up our health spec, which is a fast-drying interior latex paint. It's excellent for children's rooms because it has the scrubbability factor. The other great thing about it is that because it is a flat paint, we can actually roll the ceiling and walls, which is what you have to do on a job this size to save time. So we can actually roll the ceiling and walls and then go ahead and cut in after I'm done rolling. There's really no rhyme or reason to this rolling pattern right now. Since it is a flat, it would all dry in a nice even finish. The other great thing about this Sherwin-Williams product is actually the primer that we're using. This primer is called High Build Primer, and it enables us to actually spray, which is what we did for the prime coat. We sprayed on a coat of this, and it actually reduces the amount of sanding you have to do before prep. Fills in all the pits, valleys, any inconsistencies in the surface, and allows for a nice even finish. Another thing about this health spec is that it's got low VOCs, low volatile organic compounds, which basically means that you can use it in nurseries, schools, or in this situation, an environment where there's a lot of construction going on, a lot of people in and out. Low fumes, therefore you're not really ruining anyone's day. Okay, I think we're ready for Mike to jump up here and start cutting in. And what Michael's going to be doing is he's actually going to be going up now and what we call cutting in. He's going to be cutting in the ceiling and the walls. And that's the benefit with the health spec, is that we're able to cut in both ceiling and walls, one-time application. Speeds up productivity at least 25%. Another great tool to use when you're cutting in is a nice nylon bristled brush when using latex paints. As we like to say in the business, as painters, we create the illusion of perfection.
Well, there's still a few rooms inside the house that need to be painted. Outside, the painting will be complete within minutes practically. And of course, you know, one thing that I neglected to say was that a whole group of volunteers spent quite a bit of time caulking and prepping and getting the siding ready for paint. The thing that's interesting is when you have this many volunteers, How do you manage them? Let's meet Jim Kaloran from Habitat.
Hi, Bob.
That's the question, Jim.
Well, it's a real challenge, but it's what Habitat is all about. We have about 200 volunteers here today from corporations, churches, and from the community.
Do you give them some training before you let them loose?
Every morning we have a volunteer orientation to tell them to be ready at our volunteer site. We call 10 over, 20 over to come over to a certain part of the project.
So you group them and give them tasks?
Right, exactly. So we have rakers, we have painters, we've had siders.
Yeah.
It's a great group effort of 200 people today.
You're doing a great job.
Thanks a lot, Bob.
All right. When we come back, we'll be at the Simpson Door manufacturing plant in McCleary, Washington. We're at the Simpson Door plant in McCleary, Washington with Jim Fielder, who's the plant manager here, and we're going to show you how they make the doors. Now, Jim, this is the land of Douglas fir, one of my favorite lumbers.
That's right.
Do you mill it here? Or?
That's right, Bob. We buy the Douglas fir rough green from the sawmills.
Right.
We bring it in, we dry it, we surface it, we cross-cut it, and machine it, and actually assemble the doors here.
How many doors a day?
We do about 3,000 doors per day.
That's pretty impressive. Where do you want to get started?
Well, let's start with the processing.
All right, Jim, tell us what's going on here.
Well, Bob, as you recall, all the lumber coming out of the kiln is only 5 inches wide. And as you recall as well, a lot of our doors, the rails and panels are 12, 14, 16 inches wide. At this location, we're going to start edge gluing this 5-inch material to maximize for width for those specific rails and panel lengths that we need.
Okay, so you're basically gluing them together widthwise.
Exactly. We're putting a gluable edge on this, and this machine then is extruding a line of glue. And at this location, those pieces of wood are laminated together. Here we have a resaw operation. The material that will end up as panels has to be very strong, so we saw it into 3 pieces and re-glue it, reversing the grain of the wood for extra strength. Another way we maximize the use of our lumber is to put it through the finger joiner. This then becomes the wood used for the stiles of the doors. The material used in rails and stiles receives a 1/16 inch veneer on both sides.
So at this point, we're still talking about the raw material for the stiles, which are the vertical parts of the doors.
Correct.
The rails, which are horizontal.
Correct.
And then the ones that are all glued up will become the panels. And because
Correct.
of all the reverse grain direction, you get extra strength.
That's correct.
All right, I want to see a door coming together. Where do we go?
Let's go over to assembly.
Okay, so this is pay dirt over here,
This
right?
is it. This is it. Bob, this is the assembly area. This is where everything finally comes together, all the stiles, the rails, the panels. And as you can see, he's just going to sap this door together. Now, the stiles are the only thing that's glued. The dowel holes are injected with glue, and the
Okay.
rest of it is free.
It's important that the panels be allowed to kind of move loosely as the weather makes the door expand or contract so that they don't crack.
Exactly,
Yeah.
exactly. Yep. And we go through a loose layup process. The door is just loosely assembled, as you can see, and then it's passed on to the hydraulics to be squeezed together.
So over here, the mechanicals take over.
That's right.
Wow. You know, it's interesting. I didn't really realize that the panels themselves were that complicated. I assumed it was just regular wood.
Yeah, no, it's quite a process for panels. We have a lot of different sizes as well.
It's really an engineered wood product. What's she doing with these metal things?
Well, these are the templates to ensure that when we squeeze that door up, that it squeezes up evenly. And that's the finished product.
That's
basically.
it? You don't have to clamp it down? Or...
Nope. From here on, out it goes to the sander, goes through a pre-fit to be squared up, goes through a final inspection process, and then on to the customer.
And you're making 3,000 a day, 15,000 a week. That's a lot of doors.
A lot of doors, isn't it?
Thanks for the tour, Jeff.
Thank you, Bob. Appreciate it.
Coming up next, Ryley will be installing the basement door, so stick around.
Well, I'm here with Steve Parks, and he's hanging all of our doors for us. And this door is not a typical split jam door. Steve, could you tell us what this door looked like when you first saw it?
Well, when we got it, it was raw blank. It was, we then thinned a coat of polyurethane and sanded between coats, so it now has 3 coats of polyurethane on it.
So it's got a really good seal on it that's going to prevent any moisture from getting in and out of it.
Especially the edge and top where the veneer is exposed.
Right, okay.
We then routed the side of the door and the jam stock, which came in pieces, and assembled to the size of the door.
Okay. And you also have already checked this jam here for plumb.
For plumb.
Which is the hinge side of the door. So
If that side's plumb, the rest of the door is plumb.
the next thing you would do is just...
Attach the hinge side to the plumb jam, and then I can work the rest of the casing to the opening if it is not plumb.
Okay, let's give it a try. Come to me a little bit. Okay.
Okay, now if I can tack the top,
Okay.
holding flush to the front face, and on the side off the door so we can check its swing, see that it doesn't bind. Okay, we've got the clearance.
Yeah.
We know that the jack is plumb, so we can make this safer. Now, with some shims, we can follow along the jam. Now, I like to oppose the shim so that it doesn't roll the jam.
We've got one shingle coming in from each side.
Okay, and we can
Okay.
check the reveal.
Okay, that's got to come in about a 3/16 of an inch.
Okay. Not enough. Getting a bow here.
Yep, we're getting a bow in the middle.
Some shims just to keep it from bouncing while you nail it. But nailed at 3 points will hold it in place.
Good. Okay,
How's the reveal?
top in the middle is good. The bottom's got to come in some. That looks good.
Okay, now there's no need to set those nails till the casing goes on. Then the casing, which has been back primed, again, just to
Okay.
keep it from moving so much with the different moisture. And I like to attach
Okay.
the casing to the jam first. Hang on, let me get
Which one do you like?
the smaller pin gun for the inside, and then the longer nails for into the jack stud. And this too will help hold the casing in place. Excuse me, the jam.
Bring it up a little bit, Steve.
Okay.
Right there, it's good.
Now the 1/4 inch reveal is a little more forgiving than trying to go flush with the edge of the door.
Yeah, that's kind of standard, that 1/4 inch reveal.
Oop.
Wait a minute. Okay, right about there.
It also allows for clearance to the hinge. And now I can truly secure the door with the larger nails in the outside of the casing. Have a header that, starting again into the jamb. How's that? That'll roll out. Very nice. And also attaching to the casing first allows you to perhaps take in some of the belly of the wall by bringing them together. Nailing across the 45.
Okay.
We'll keep them flush.
Well, that looks great, but isn't there something missing down here?
Doorknob. Better to bore on site in case this had to be adjusted for height.
Right. So now when we put in the knob set and the whole latch mechanism, there's not going to be any problem of them not lining up.
Correct.
When you do them on site this way. That looks great, Steve. Good job.
Thank you.
Next, we'll use an infrared camera to test the SIPS panel insulation. Don't go away. Our Habitat for Humanity house has been constructed using SIPs, or structural insulated panels. They're a sandwich of oriented strand board and rigid insulation. We can do a neighborhood comparison of the efficiency of this insulation by using an infrared camera. Let's get together with Ren Anderson from the National Renewable Energy Labs and see how it works. So Ren, explain this to me. I mean, I've heard of infrared before, but now we're coupling it with housing and insulation here, right?
Yes. We're using it as a tool to evaluate the performance of the houses. As you can see on the screen here, Bob, we have colors going from very dark colors through blues and violets to red with increasing temperature through to yellow, and then white is the hottest temperature.
Mm-hmm. So that's me right there.
That's you. And you can see that your body, where you have a coat on, is cooler. It's in the red zone. Your face, which is bare skin, is yellow, indicating that it's warmer.
And my nose is darker still.
Your nose is being naturally cooled as you breathe. Every
As
breath
you breathe.
cools it down.
This thing is amazing.
Yep.
So take us one more step and show us some of the still shots that you've taken in the neighborhood.
Well, over here we have still shots that I took yesterday morning of the neighborhood showing what I call the good, the bad, and the ugly series.
So the ugly is the one on the left-hand side?
Yes, this is an older house. It was built some time ago. It has uninsulated walls and single-pane windows, and you can see by the white colors that we're losing a lot of heat out of this building.
It's an apartment house, right?
That's right.
Is it brick?
It's a brick exterior.
And so you shouldn't necessarily think that if you have a brick house that you have an insulated house, because in fact you can have a lot of heat loss through the brick.
That's right. Now the next house up is a house that was built more recently across the street from our house. It has insulated walls, double pane windows, and you can see from the colors relative to the house below, the windows are cooler, indicating better performance, and the walls are much cooler, indicating that the insulation is working. You can also see that the roof line is not losing heat. It's also relatively cool.
And what about our house?
You can see our house, the windows are even cooler than the house across the street, indicating that the low-E argon-filled glass is working extremely well.
Cool.
The walls show a slight blue color, indicating that they're performing better than the house across the street. And the big winner is the roof line, which is extremely cold, indicating that the SIP panels are working extremely well on the roof.
We've got an R30.
Absolutely. So in summary, this tool allows us to demonstrate that we have an Energy Star house.
Eureka!
Eureka!
Terrific. That's a wrap for today. Come home again next time when we'll be working on the interior finishes. Riley will be in the kitchen with Steve Yates installing a Pergo laminate floor. We'll see how to make a transition from vinyl floor covering to Pergo. Also, Riley will be getting together with our architect, Ed Binkley, to work on a built-in shelf system for the loft area. Till then, I'm Bob Vila. It's good to have you home again. For lots of information and resources for your home improvement project, check out my website at bobvila.com.